Hello, my name is Sean Mitchell. I'm an engineer in the Technical Training Department at Yaskawa America. I will be your instructor today as we go through this e-learning module. The purpose of this e-learning module, or ELM, is to help you do a simplified, quick and easy startup of a pre-installed, pre-programmed E7L or E7B with option Y. Basically any drive bypass with a keypad that looks like this. The catch is that the procedure is only simple if the drive bypass has been programmed and wired correctly. Wiring is done on the I/O board on the left wall of the cabinet as shown here. The functionality of each terminal on the Green Phoenix connector will be talked about later. Programming is done with a combination of dip switch settings on the I/O board and parameter settings in the drive. If you have everything wired correctly for your application but the programming is wrong, your drive bypass will not function. If you have the drive bypass programmed correctly for your application but the control wiring is hooked up to the wrong terminals, your drive bypass will not function. With either one of these scenarios, the unit will not operate the way that it should and the way that I will describe in this e-learning module. Let me go ahead and give you a simple example. If your unit is programmed for a 4 to 20 milliamp speed reference input and your BAS is outputting 0 to 10 volts, then obviously the bypass will not be running the motor at the speed that it should be. So, where can you find information about programming your drive bypass? There are several places linked under the Attachments tab. The most obvious one is your E7L or E7B Drive Bypass Technical Manual. What, you thought this presentation would save you from having to read anything? I don't think so. Here is one of the many important charts in the manual. This one is from page 217 of the E7L Tech Manual and is a summary of all the dip switches. Two especially important dip switches are S2-7 and S2-8. These switches tell the bypass if you have a normally closed safety interlock and a normally open damper end switch. It only takes one of these tiny little switches set in the wrong position to keep your motor from running. This ELM will not teach you what a drive bypass is and what it does. It is assumed that you know this already. Okay, now that I have told you everything that you ever wanted to know about what we will not cover, I will finally tell you what we will cover. My goal in this presentation is to teach you a few of the most important steps when doing a startup on an E7L or E7B with option Y drive bypass. The procedure outlined here is a stripped-down version of the startup procedure found in Chapter 4 of your Drive Bypass Tech Manual. I strongly advise you to look through that checklist in addition to watching this presentation. The first item on our startup procedure is to make sure that you don't electrocute yourself. If you get this step wrong, you're really not going to need to know how to do the remaining steps. You'll need to shut off incoming power to the unit. Next, we need to make sure that certain screws are tight, namely the terminals L1, 2, and 3 for the input power, and output terminal screws T1, 2, and 3 to the motor are nice and tight. These input and output conductors carry a good amount of current into and out of the cabinet. We'll need to make sure that the OLR or overload relay is set to provide adequate protection to the motor. The E7L pictured here does not have input current protection. If your unit does, it may look something like this, and will have a dial that will also need to be set. Next, I will cover the functions of each terminal on the I/O board. This is where you will hook things up like your auto mode speed command and run command from the BAS. As a trainer, I do enjoy beating dead horses, so please note that although I will be explaining the functions of the terminals, I will not be explaining how to program the drive and I/O board dip switches. The Keypad Operation section will show you how to use the bypass portion of the keypad and teach you some very basic functionality like what buttons to push in order to run the motor off the line. We even give you a simulation to verify that you know how to operate the drive bypass. Once you know how to use the keypad, you'll be capable of making the motor rotate. But what if it rotates in the wrong direction in drive mode but the right direction in bypass, or vice versa? We'll show you how to correct motor rotation in the final section. I would like to take this time to mention that the drive bypass comes in many different sizes. The 2-contactor E7L ranges from 1/2 to 60 horse, and the 3-contactor E7B ranges from the 1/2 horsepower infant to the 500 horsepower giant. Pictured here on the left is a 1/2 horsepower wall mount E7L. On the right is a 250 horse floor mount E7B with touchpad option. Although there are many differences in the physical appearance between the two units, such as external door switches and internal contactors, the functionality is the same. So if you walk up to a drive bypass in the field and it doesn't look exactly like the ones pictured here, don't be discouraged. All units do share identical keypads and control boards. Let's get started with the first section that deals with the removal of input power. Before you open the cabinet, be sure to remove input power and check the voltage with a meter before putting a screwdriver on any terminals. Obviously, we're working with high voltage equipment. This chart shows us that an electric shaver can pass enough current to be fatal. An E7L or E7B can put a little bit more current through you than an electric shaver. So, as I was saying, first we remove the main power. Also, make sure to put a lock on so that no one can turn the power back on while you're in the cabinet. Once that is done, I need to open the cabinet. For my drive bypass, which happens to be the 2-contactor E7L, this involves turning 2 set screws as well as turning off the power switch at the front of the enclosure. Now that the door is open, make sure there is no input voltage using a multimeter by checking the voltage on all 3 phases. This includes L1, L2, L1, L3, and L2, L3. You should also take this time to make sure there are no obvious wiring mistakes, especially in the high current wiring. That is, make sure that the line power, output to motor, and the output to drive are where they should be. Have your schematic handy. The next step is practically self-explanatory, but I think I'm going to explain it anyway. We need to tighten the line input and motor output screw terminals. In fact, it is a good idea to go ahead and make sure that all the wiring, especially power wiring, is nice and snug. Loose wire connections can cause intermittent problems and overheating. We need to verify that the terminal screws for the input power are nice and snug. You should already know exactly where these screws are because you just put the voltage probes of your multimeter on them. Check all 3 screws as well as the ground lug. If you must be precise about it, there is actually a torque spec for each disconnect listed on page 2-3 of your bypass tech manual. For the drive bypass that I am using, this happens to be 15 inch-pounds. I also need you to snug up the screws on the motor side. This is done at the adjustable thermal OLR, mounted electrically after the K3 bypass contactor. Physically, the OLR will be located either directly above K3 as shown here for lower horsepower units, or to the back wall of the enclosure in the case of higher horsepower models. The OLR is set up at the factory to be a manual reset device, requiring operator attention if an overload trip occurs. Again, be sure to snug up all 3 lines in addition to the ground. Next, we'll walk through setting the input and output current protection levels. By now you may have noticed the dial on the OLR. It is used to set the trip current for your motor. Line the arrow up with the number on the wheel, but what number do you pick? This dial should be set to the full load amps from the motor nameplate. At this time you're actually going to have to do something. I want you to locate and click the current rating that should be set on the blue dial. Assume this marathon motor is wired for 460 volt operation. If you absolutely can't find the answer, click anywhere on the nameplate and a help box will appear. If your drive bypass has a square D motor circuit protector like the one shown here, you'll need to set the magnetic trip level using a dial. The device is not standard for the E7L. If you have a 3-contactor E7B, then the device is standard. The magnetic trip setting has a much higher value than the breaker itself to allow for inrush current. Setting the MCP is step 11 of the startup procedure in chapter 4 of your manual. There are 2 ways to set the inrush trip current. The first one is what is done in the manual. With this method, you just set the dial to 10 times the motor FLA for fan applications or 6 times the motor FLA for pump applications. The second method allows you to more accurately set the breaker to your specific application. Here, you set the dial to its lowest setting and then run the motor in bypass mode across the line. If the breaker doesn't trip the first time, you're done. If it does trip, increase the setting and start the motor again. Repeat the procedure each time increasing the trip setting until the lowest setting on the dial that won't trip upon startup is found. A clamp-on current meter can be a handy tool to help you find the inrush current for your application. A couple of side notes. Number 1. Once you find the setting, make sure to try it a couple times and make sure the result is repeatable. And number 2, if you're using the trial and error method, you'll want to make sure that the motor is spinning in the correct direction first. We'll cover that later. Also, don't forget to take into account things like damper or valve position when running or starting full speed across the line. Obviously, the BAS in your application needs to communicate with the bypass and tell it when and how fast to run, among other things. These signals are just a couple of the functions possible with the control board or I/O board. Let's take a closer look. If you're familiar with drives in general, you know that there are different types of inputs and outputs to perform a variety of different functions. There are digital inputs and outputs, as well as analog inputs and outputs. Just like a drive, the drive bypass also has inputs and outputs, analog and digital. Chapter 2 of your user manual will tell you what you need to know about the terminal board and control wiring. I'll go ahead and mention the specific page numbers at the appropriate time. First, we will go over the terminals in groups together. Then you'll have an opportunity to explore the details within each group on your own. Here's the digital input section of the control board. Anytime a switch is closed between terminal 9 and terminals 1 through 5, the corresponding function is activated. The symbol on the sticker tells whether the function is normally open or normally closed. Next, we move to the digital outputs. These terminals are just relay outputs. So for example, anytime the motor is running, a short will be seen on terminal block 1 or TB1 between pins 10 and 11. So if you want a light to turn on somewhere for a motor run, you'll need to provide your own power. The remaining digital outputs work in the same way, except that they can be programmed with the dip switches to turn on and off for different functions. All contacts are rated for 5 amps, 120 volts AC. See page 2-9 in your user manual for dip switch settings. The I/O board has 2 analog input terminals for use as an auto mode speed command, speed pot, or PID feedback input. The signal level of the A1 terminal is 0 to 10 volts DC only, while A2 can be set for 0 to 10 volts DC or 4 to 20 milliamps depending on the state of dip switch S1-2 and drive parameter H308. See page 211 for more information. Last but certainly not least are the analog outputs. There are 2 of them, and unlike the analog inputs, both of these babies can be configured for 0 to 10 or 4 to 20. Signal levels are chosen using jumpers J2 and J3. Notice that the analog ins and outs electrically share the same ground terminal. The E7 drive, and therefore the E7L or E7B drive bypass, has the ability to talk to your BAS via embedded serial communications for the popular building automation protocols like Johnson Controls Metasys N2, Siemens Apogee FLN, as well as Modbus. Also available is a LonWorks interface card. I will give you a break from my talking and let you explore the different functions of the control board on your own. Place your mouse cursor over the terminal names to learn more about each one. Under the Attachments tab, you'll find a printable document with the same information. Part of my responsibility during this module is to teach you how to correct the direction of motor rotation. In order for you to do this, I must first show you how to rotate the motor using the keypad on the front panel. The keypad is composed of 2 main sections. The top half is the same one that you would find on any Yaskawa drive, except that the run and stop buttons have been removed. Use this section for drive programming. The drive bypass contains its own run and stop commands on the lower half of the keypad. This will be our main focus here. See Chapter 3 of your tech manual for more information. Let's start with the status LEDs. There are 3 possible colors among all the LEDs, but each individual light can have only one color. Also, the keypad shown here is with all of the LEDs on, so that you can see the color for each one. In reality, it is not possible to make all of the LEDs light up at once. For example, the drive bypass can only be in one of the hand-off or auto modes. It cannot be in 2 different modes at the same time. In general, green means normal status. The top auto run LED will only be on when the unit is in auto mode. That is when the BAS is supplying the speed reference and the run command to the bypass. The control power LED tells us that 3-phase power has been applied to the unit and that the control power transformer is functioning correctly. The drive select LED lights up when in drive mode. That is, the contactor that connects the drive to the motor is closed and the contactor between the line and the motor is open. Ready indicates that there are no problems, and the green run turns on when the motor is running off the drive. And finally, the auto LED turns on when in auto mode. Under normal operating circumstances, all 6 of these LEDs will be on. Amber is used to indicate an abnormal situation. It does not necessarily mean that there is a problem, prevent the motor from running, or indicate that your system is not programmed or wired correctly. For example, being in hand mode or running in bypass is signaled with amber. If the drive faults and you have the drive bypass programmed to automatically transfer to bypass, the auto transfer light will blink while the motor is running off the line as a result of the fault. Smoke purge will light up when the smoke purge function is activated by a building fire control system. When in drive test mode, the drive can be operated via the local control panel while the motor is running in bypass. Putting the E7L or E7B with option Y drive bypass in hand mode will allow you to run the motor by hand, meaning with the keypad. Hand mode will act as the run command in either drive or bypass mode. As you might expect, the off light goes on when the off button is pressed. The bypass light goes on upon pushing the bypass select button. This puts the unit into bypass mode. The amber bypass run light comes on anytime the motor is running offline power. A red LED indicates a fault condition, which will prevent the motor from rotating. Safety open, and damper BAS will light if either of these terminals on the control board are not taken care of using the methods described in the last section. The drive fault indicates a drive fault, as you could have guessed. The motor OL light comes on when the motor overload has been tripped and needs to be reset. The hand button is the key to making the motor run using the keypad. Push hand while in drive mode and make the motor run off the drive. Hit off to stop the motor. Pushing hand while in bypass mode will make the motor run off line power. These two functionalities are achieved by closing and opening the switches or the contactors shown on this schematic. A contactor closing sounds like this, while a contactor opening sounds like this. Again, you know that you're in drive or bypass mode by observing whether the green drive select or the amber bypass select LED is lit. Now is your chance to actually learn to use the keypad. Once you feel confident that you can do each of the 5 tasks on your own, navigate to the next slide as you normally would to use the bypass simulation. Here you will have to click on the keypad buttons to operate the bypass. Okay, you're on your own until the next section of the module. I'll see you there and good luck. The motor is now running off the drive. The default frequency is 6 Hz, as shown in monitor U102. To change the frequency reference, highlight the monitor U101 using the down arrow. Then hit Data Enter. Push the up arrow to increase the frequency. In this section, I will help you make sure that your blowers blow and don't rotate in the wrong direction. That is, I'll show you how to correct the direction of motor rotation if it is wrong. The steps that follow have to be done in order if you want the following procedure to work. This section of the ELM deals with Step 6 and Step 12 of the startup procedure found in Chapter 4. Let me give a quick definition to help us get through the next couple of slides. To bump the motor means to quickly turn the motor on and then off. We do this for equipment protection, since your system was meant to spin only one way. So to check drive mode rotation, bump the motor in drive mode. If the direction is correct, it's your lucky day. You can go on to the next step. If your life runs according to Murphy's Law like it does for the rest of us, the motor rotates the wrong way and you'll have to correct it. To do this, turn the drive bypass power off. Wait for the caps to discharge and the corresponding charge LED to fade out. You should check the DC bus voltage with the meter to make sure. Never trust the charge LED. Then swap wires T1 and T2 on the motor overload protector. Once this is done, power the unit back up and bump the motor again in drive mode to verify that the direction has in fact changed. Now switch over to bypass mode and do pretty much the same thing. That is, bump the motor. If the direction is correct, you're done. If not, you'll have to swap two of the input wires, L1 and L2. But before you do, make sure you remove incoming power to the bypass and check it with a meter as always. Once this is done, you'll need to bump the motor one last time to verify the correct direction. Now it's your turn to prove that you can do this again on your own with another simulation. So, you've managed to make it through another Yaskawa ELM. Congratulations. Thank you for attending this Yaskawa e-learning module. We greatly appreciate you taking the time to learn more about our products. If you would like any additional training, please contact us through any of the methods shown here. Thanks again, and have a great day.